let's test now. Okay, we have a green light. Okay, wait, what happened? So it's stuck at 52.052 milliamps. Have we got the 3.42 now? Voltage range. Okay, we have a 3.42. Or do we have 8.6? This is where you check 8.6 voltage. So we have 8.6, 3.42. Do we have other voltages? No. 3.3 is available, which is here, and then we will check. Okay, so it's not there, not there. So we will check the next signal we are going to check is the AC OK signal. Let's check the AC OK signal, which is usually here at this point. It's the third resistor, possibly this one. Yeah, do we get AC OK? So AC OK is fine. Now next thing we are going to check is here on the top, which is reset signal, SMC reset underscore L. Do we have SMC reset underscore L? So 3.3 is okay here. The next area is the RTC VCC area. Let's check that. I'm looking for this signal, which is RTC VCC. So RTC VCC G3 hot, and this is where we're going to look if this area is working fine. Let's check it. So 3.3. You see here we have 3.3 here, but after this resistor we are not receiving 3.3. So RTC signal is 3.3 volt, and there is like 4 of these resistors. So these are the 4 resistors we are looking at right now: R1300, R1303, R1302, and R1301. So we have a 3.3 volt coming here on the pin number 1, and it should also be here at pin number 2, unless there is a shortage, so it won't come here, or this resistor is gone faulty, maybe it's changed its value. And similarly R1303. So anything close by 3.3 should work, but if it's completely disappeared, this 3.3, then it means we need to look for the reason why this 3.3 is disappeared. So let's check this area. So the first resistor is R1300. This is the first one I looked at, and this is where I found one problem, but we need to check R1301, 302, and 303 also. Let's check these. So we're receiving 3 volt here, 3 volt here, 3 volt here, 3.1 is okay, 3.3 and 2.8 is also fine because it's a higher value resistor. R1301, yeah, is this resistor here, is in mega ohm. The resistance is in 1 mega ohm, that's why from 3.3 is changed to 2.8. Okay, so they looks good so far, but this one, if you look here, is 3.3, and at this point is 0.044. So something is not right here. Let's check what it is. Is it the resistor, or there is a shortage? If there is a shortage, then then this shortage is going into the CPU. You can see this is the U050 Broadwell ULT. So let's see, because after this resistor, you can see here the pin number 1 is the 3.3 volt here, but pin number 2 is probably right going into the CPU here. So only this part, if this area is shorted, then this video has no happy endings. Okay, let's check the value on this resistor. In the resistance mode, let's check. So it's supposed to be one. What is the value of this resistor? It's showing 14 kilo ohm. 15 kilo ohm, but it's changing also. I don't know, maybe I don't have a good contact. Let's check again. Yeah, 14 kilo ohm, and what is supposed to be is 20 kilo ohm. Oh, it's nearly there, so could be right. Let's check one more thing. Is there any short here? If there is a shortage, then there is a problem. Okay, because it's going in the CPU. You say I'm in the diode range at the moment, and it's a healthy value here, diode mode value here, 0.433, but when it comes here it's become 0.17, which I cannot doubt at the moment, because this RTC VCC, this connection at R1300 is going into the CPU, and anything that is going into the CPU has a low resistance. So I think I should just change this resistor also. I should change this resistor. Finger cross. And I can also check this. Let's check in the beep range one more time. So what is in the beep range? What is happening here on this capacitor? Yeah, 21 ohm. So 21 ohm is not bad actually, but can you see that? I want to take this resistor now. Okay, and again I'm going to use the same donor board from the donor board. Let's change it. Sometimes the resistor shows a healthy value, but when it's in the working condition, it is faulty. It increases its resistance, and that can cause any issue, you know. So even after changing this resistor, we have the same problem. Then our CPU could be faulty. Come on, this hot air is good, but it's a bit slow. Oh, where is he gone? Is he disappeared? Oh no. Where did he go? Not supposed to go. Oh, once it's gone, it's gone. We can't find it anymore. Oh, so he's disappeared. I'm sorry. I need to look again. And that's what we want. The first one disappeared. Okay. This is our resistor. So before I lose it, I'll just put it here. Put some flux here, so this does not go anywhere. Yep. So we're going to remove this one and replace one. Surprisingly, RTC VCC section is usually ignored, but this is the first in the first signals after you have received your PP3V42. You have some basic voltages, and your MacBook is still not triggering. I mean, is not generating all the voltages. Then this is probably in the line of all the signals. This is probably the first ones, RTC, VCC. So we have removed this resistor also, and now we will just give it a little bit clean here. And see, let's clean a little bit more. So let's see our board. Just cool it down a little bit faster with this isopropyl. Voltage range. We are receiving 3.3 here, and we are receiving 3.3. That's good sign. Okay, maybe 3 with that's fine. That's fine. That's fine. So our RTC voltage is complete. We have no issues now in the RTC voltage. Okay, now let's check. Power it on.
If it's done, I'll call you a message.
Ah, it's still stuck here. So that's not fair.